Guys, what is going on? This is Mikey Games here, and today we're going to be going over the binary search algorithm. This is another algorithm, like the linear search that I did yesterday, put a video out, and it's basically a way more efficient searching algorithm. So first, to understand the binary search algorithm, we're going to have a look at a binary tree. So basically what a binary tree is, it's comprised of multiple nodes, and a node is usually shown by a circle with, say, a number or a value in. So let's put this as 3. And every node to the right of its parent node, so if I make a node here, right, this node here is this node's parent node. Every node to the right of it has to be greater than its parent node. So I cannot put this as 2. This has to be larger than 3. So let's put this as 5. And then everything to the left hand side has to be smaller. So let's say 2. And then you can kind of keep going with that. So I can say here I can put 4. So as you can see, 4 is smaller than 5. So it goes on the left-hand side. However, 4 is larger than 3, but is still on the right-hand side pathway to 4. So that's basically the binary tree basics. We're going to need to know a bit about that to implement the binary search, but if you want to learn a bit more, you can go away and have a look at that yourself. So, let's get rid of this. So basically, let's create a list. Let's say x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mind my my incredibly great mouse drawings. So with the binary search algorithm, what we do is we basically pretend that this is the most efficient binary tree possible. When I say the most efficient binary tree is, you can arrange this set of data into multiple binary trees. So I could say, I could go 10. I couldn't put 9 here, but I could just go 9, 8, and so on. But then I'd have an incredibly long binary tree. And the point with the binary tree is to get the most efficient binary tree is the binary tree with the least amount of levels. When I say levels, I mean the amount of links it has on the same level from how many nodes it's got from the main node. So the way to make the most efficient binary tree is basically you go to the middle of your data set, and then you take that and you make that as your main starting off node. And then you go on so forth, so then it would be, and then you have to go halfway again to make it even more efficient. So we would go for 8, and then on the side of 8 we would put, say, 7, then 9, and then we would put 6, and then 10. I mean, these can be swapped around. You can put 10. You could put 10 there and then 9 coming down this way, but it doesn't matter. As you can see with this one, we only have 1, 2, 3, 4 levels. Whereas if I did it with the 10, 9, 8, 7, 6, and so forth, we would have 10 levels. So it'd be a much more, less efficient tree. So that's basically the way a search algorithm works. What we do is we go to the midpoint, which is 5, and we check, is 5 equal to the number that we're searching for? And also with this we also check the end, so we're going to have 3 variables. So we're going to have the end variable here, we have the start variable, and then we're going to have the midpoint. We're going to check if any of these variables equal to the one we're looking for. And if it isn't, what we're going to say is the variable that we're looking for larger or smaller than 5? So say it's smaller than 5, there's no point in having a look at this side of the tree, because we know, because as this is a sorted list, we know that this side is irrelevant. We know that anything above 5 is going to be completely irrelevant to what we're looking for. We know our item is not going to be in there. So we can basically we can split the list in half and basically create 2 lists. And then we can just disregard this side of the list and say we have just a smaller list here. And then we can set the endpoint, the new endpoint can be here, and the start point can say the same. And then we find the midpoint of this list, which would be 3. And then we check again, is the end, the start, and the mid equal to the item that we're searching for. Although, to be honest, as you go through the iterations, you won't need to check the end or the start, but only for we're going to have to do that just to check the start and the end point anyway. And then we check for 3. If it's not 3, then we have to go, is it larger or smaller than 3? So say it's 2, 2 is smaller than 3, so we're going to split this list in half again, and then 2 is going to be our midpoint, and then when we check, so this part of the list goes away, when we check our midpoint, it's going to equal true, and we can return true. So that's basically the way we're going to code it. So let's go over to Python. So this is, I've already created this algorithm just to speed stuff up. So what this does, it creates a sorted list. Well, actually, let's go back a second and let's look at the advantages and disadvantages of the binary search tree. So, the advantage is basically it's an incredibly fast algorithm. The maximum number, say, for this list of 10 is going to be 3. Three iterations that you're going to have to look for. So the first iteration, the midpoint is going to be 5, then the next one is going to be 3, and then the next one is going to be 2. And we can't go any further. We can't start splitting down here or down here because we've got nothing else down there to split. So in a 10 long list, it will only be 3 iterations. Whereas if we compare it to the linear list, the most iterations that it goes through is 10. So if we're looking for 10, which might be right at the end, we'd have to go through the entire list, we have to iterate through it 10 times. Whereas in the binary search, we only have to do it 3. So as you can see, it's a great save in efficiency. Disadvantage, however, we have to have a sorted list. Without a sorted list, it would be pointless and this algorithm wouldn't work. So therefore, if you do get random data, you're going to have to use a sorting algorithm before you can use a binary search algorithm, which may take more time than just a linear search. Okay, now let's go on to coding. So this creates a list between 1 and 10. It's just list comprehension. So here we create the function. So this is the value that we're searching for, and D is the list that we're putting in to search the value for. And then what we're going to have 3 variables, as I said before, the start, which is going to be 0. So these are the positions within the list. So the start is 0, which is the first item of the list, as item indexing starts always at 0. The midpoint we've just set to 0 for now, but we will change that. And then the end point, we want to be the last item in length. So it's the length of D minus 1, because obviously iterating starts at 0, so we're going to have to take 1 away from the length of the list. So what we're going to do, we're going to iterate through the list. We can take this out, and we're going to have to set the midpoint every time we iterate through this list. So the midpoint is going to be the integer of the end plus start divided by 2. And that will get us the midpoint of the list. And then we need 3 if statements here. So as I said, the first if statement is going to check, is the middle value equal to the value that we're looking for? Or is the end value that we're looking for, or the start value that we're looking for. So then we move on. If it isn't, if it is, we're going to return true. We're going to break out of this loop, break out of the function, and then we're going to go back. If that isn't not the case, we're going to have a look at our next if statement. So our next messing up my words there. If our next if statement says, is the midpoint smaller than the value? Now, if the midpoint is smaller than the value, we're going to be looking here with our example. Our value is going to be smaller than the midpoint, which is 5. We're going to need to look at just this side of the tree. Let's get rid of this for a second. I'm going to look at this side of the tree. And for that reason, we're going to set the endpoint to the current midpoint. So our current midpoint is 5. Our current endpoint is 10. We don't want to know about the rest of this part of the list. So the endpoint now is going to be set to 5. So this is now our current endpoint. This is our start endpoint. This part of the list has been disregarded. We've essentially got ourselves a new list. And then what it's going to do, it's not going to trigger this if statement. We're going to then go back and it's going to set a new midpoint. Our midpoint would be 3. And then it would check and then it would carry on. So let's have a look at this other if statement. So basically it's the opposite. So is the midpoint larger? Or sorry, is the midpoint smaller than the value? And if so, we don't want to know about this part of the list. This can go away, and we're really interested in just this part of the list. So to do that, what we're going to do, we're going to set the start point now, not the end point, the start point to the middle value. So our start point was 1, and we're going to move it, and our start point is now going to be 5, end point is still going to be 10, and on the next iteration we're going to set the midpoint to 8. So let's have a look to see if this works. So we're going to call the function here. We're going to put in 3, we're going to put x, which is our list, and let's run this. So as you can see, 3 is within that list, and we're giving true. Yes, 3 is within this list. So what it's doing here, let's get rid of this. It's having a look, setting the midpoint. Let me get this back up, right? So it's setting the midpoint, which is 5. Is the midpoint, is value is equal to the midpoint, endpoint, or start point? No, it's not. So, is the midpoint larger than the value? We've put in 3. So yes, it is larger than the value. So we're going to disregard this part of the list. We are now going to set the endpoint to the current midpoint. And we're going to have a look at this side of the list. Next iteration comes, we're going to set the midpoint to 3, and then our first if statement is mid equal to value? Our mid is 3, we put in 3, so our value is 3, yes it is, returns true, and ta-da, it works. So that's it for now. Stay tuned guys for more videos like this, and peace out.